class. In this chapter, we're going to learn about the electric charge and electric field. Looking ahead, these next few chapters will develop the idea about electricity, as well as the relation to magnetism. The word electricity comes from the Greek word electron, which means amber. Amber is a petrified tree resin, and the ancients knew that if you rub a piece of amber with a cloth, the amber attracts small pieces of leaves or dust. A piece of hard rubber, a glass rod, or a plastic ruler rubbed with a cloth will also display this amber effect, or as we call it today, static electricity. You probably experienced static electricity when combing your hair or taking a synthetic shirt from the clothes dryer, and you may have felt a shock when you touched a metal door knob after walking across carpet. In each case, an object becomes charged as a result of rubbing, and it is said to possess a net electric charge. Is all the electric charge the same, or is there more than one type? In fact, there are two types of electric charge. As the following simple experiment shows, a plastic ruler suspended by a thread is vigorously rubbed with a cloth to charge it. When a second plastic ruler, which has been charged the same way, is brought close to the first, it is found that one ruler repels the other. This is shown in Figure A. Similarly, if you rub glass rod, it is brought close to the second charged glass rod, and again the repulsive force seems to act, as shown in Figure B. However, if the charged glass rod is brought close to the charged plastic ruler, it is found that they attract each other, as shown in Figure C. Thus, there seems to be two, and only two types of electric charge. Each type of electric charge repels the same type, but attracts the opposite type. So, unlike charges attract each other, whereas like charges repel. The two types of electric charges were referred to as positive and negative by Benjamin Franklin in the 1700s. Franklin argued that whenever a certain amount of charge is produced on one object, an equal amount of the opposite type of charge is produced on the other object. So during any process, the net charge and the amount of the charge produced is zero. For example, when a piece of amber is rubbed with a cloth, the amber acquires a negative charge, and the cloth acquires an equal amount of positive charge. The charges are separated, but the sum of the two is zero. This is known as a law of conservation of electric charges, which states that the net amount of electric charge produced in any process is zero, or said in another way, no net electric charge can be created or destroyed. Only within the past century it has become clear that an understanding of electricity originates from the atom itself. A simplified model of an atom is shown in having a tiny but massive positively charged nucleus surrounded by one or more negatively charged electrons. The nucleus contains protons, which are positively charged, and neutrons, which have no net electric charge. All protons and all electrons have exactly the same magnitude of electric charge, but their signs are opposite. Hence, neutral atoms have no net charge containing equal number of protons and electrons. Sometimes an atom may lose one or more of its electrons, or may gain extra electrons, in which case it will have a net positive or negative charge, and this is called an ion. In solid material, the nuclei tends to remain close to fixed positions, whereas some electrons may move quite freely. When an object is neutral, it contains equal amount of positive and negative charge. The charging of a solid object by rubbing can be explained by the transfer of electrons from one object to another. When a plastic ruler becomes negatively charged by rubbing with a cloth, the electrons are transferred from the cloth to the plastic, leaving the cloth with positive charge equal in magnitude to the negative charge acquired by the plastic. Normally, when objects are charged by rubbing, they hold their charge only for a limited time and eventually return to a neutral state. Where does the charge go? Usually, the excess charge leaks off into the water molecules in the air. This is because water molecules are polar. That is, even though they are neutral, their charge is not distributed uniformly. Thus, the extra electrons in the charged plastic ruler can leak off into the air because they're attracted to the positive end of the water molecules. A positively charged object, on the other hand, can be neutralized by transfer of loosely held electrons from the water molecules in the air. On drier days, static electricity is much more noticeable since the air contains fewer water molecules to allow leakage of charge. On humid days or rainy days, it is difficult to make any object hold a net charge for long.